Theorem of calculus. It is simply this guy right here in the red box. All this means is from a to b of f of x dx, it is, remember, big F of b and big F of a. Big F is antiderivative. So that's why we did antiderivatives before this. Okay, so antiderivative of b, so that means the antiderivative of this and plug b in. So b would be a number here, right? 0 to 5, 5 to 2, whatever. Antiderivative and plug a in. You will subtract that. Okay, any questions with that? That's the integral sign. This means integration. And this means from where? So we integrate in sections. Okay, so this would be like, we're going to do in a second, but this would be like integration from 2 to 6. So that's what we would plug in. Because if we're finding... Oh, sorry. I just lock it. Okay, so just again, review from yesterday, just to help everybody and Emily. We're finding area under the curve. So if I said from -1 to 5, let's say that's -1, that's 5, we're finding that area. But let's say maybe I say to 7. Then I also need this area. So any area under the curve to the x-axis is what we're looking for. Okay, that's what the A and the B do. They tell us from where to where. Okay. We'll take a look at example 1. What is the antiderivative? So let's just, first off, what is f of x here? Big F of x. So what's the antiderivative of x cubed? What's that? No, you went the wrong way. No. There you go. 1/4 x to the 4th plus c. We don't have to really account for c in the sense of this example, but just remember from yesterday, or from our antiderivatives. So what we're going to do, so you can kind of ignore c. We don't need to use c right now. Okay, 1/4 the x to the 4th. So we're going to do big F of -1, but subtract from, so it's always this one minus this one. So 1/4 2 to the 4th minus 1/4 -1 to the 4th. So we get 2 to the 4th is 16. 16 divided by 4 is 4. That's going to be just a 1. Remember that one? We actually did that one yesterday. 3.75, remember? That's the one we got yesterday. 4 minus 1/4. Okay, any questions? Okay, let's try the second one. Sine. Okay, so first thing I'd do if I was you, what is the antiderivative of sine x? Okay, good. So negative cos x, and now we're going to do it from 2 pi to pi. Cos at 2 pi is 1, so we have a -1 here. Cos at pi is a -1 with a negative and another negative. So -2 would be your answer there. Correct. Hold on that. This is, we're just doing the integration, not necessarily the area yet. So the idea of the area will come. Just for now, just stay with fundamental theorem of calculus, and we'll handle it when we're actually doing the appropriate area. So you are right. From yesterday, we're not looking for negatives. This one somewhat is a little bit different too, because this is a sine and cosine curve, but we'll come back to that. Okay. All right. So here is, this is on your formula sheet. You don't have to write these down. But these are your table of indefinite integrals. So the couple things you're going to look for is when you see, especially things like, we're going to do this one today. When you see that, the integration of this is simply tan -1. So you want to kind of get used to that. Remember, we're not going to do any of these. Anything with the E or the LNs. Okay? We're not doing those ones because we're going to come back to logarithms. Same thing here. Okay? So this one's primarily, you can see, is mostly for your trig. Okay? This is mostly for your trig. Okay? Right. So it says that you can figure this out by doing the derivative of the right. So if I did the derivative of tan, what's the derivative of tan? Secant squared. So just telling you, if you want to check it, you can go backwards to check them. But it has a table here for you because sometimes that's kind of hard to wrap your brain around, going backwards derivatives. Okay, so they have that there for you. It's on that formula sheet I gave you. Okay? All right, so properties of integrals. So in finding antiderivatives and more complicated functions, we use the following rules. So this is the idea kind of yesterday I was kind of explaining to you that if you have a constant in front of your function, so let's say you pull a 2 out, or you pull, like, remember yesterday we pulled out like a 75/2. You can bring that in front of the integral like you could with limits. So if you pull a constant out, you can put that in front of the overall integral. So you can integrate that separately. Okay, that's all this is saying. That's very similar. And then also, if you have two functions added, so like an example of this one is if I had, let's just say I had the integration of x squared over 2x plus 1 plus 3x squared. I can break this up into 2. So I can say, okay, x squared over 2x plus 1 plus 3x squared, which is a little bit easier to handle them separately. Okay, very similar to our limit rules. Remember, we could break our limits up into, it said sum and difference rule of limits. Okay, same thing here. So just saying you can break these up. Okay, these can be verified by differentiating both sides. Okay, so this is the same thing as well. They just add the limits. We're going to do one right now where we break it up. You're going to see why, because we're going to, let me know when you're done, Emily. You good? Everybody else okay, or are we still writing? Still writing? We can wait. Just pause it here for a second, give you 20 seconds. So this is an example. Notice 6x squared plus cosecant squared x. We're going to look at those separately. One has trig and one doesn't. So we're going to write this one, and this is just it says find the general indefinite integral. So there's no a to b here. But we're going to treat it like this. We're going to do them separately. So even with that, we actually can pull the 6 out. By the other rule I said, this is going to be, if that was a square, we know it's going to be a 3 with a 1/3. Cosecant squared is the antiderivative of what? It's on the chart we just looked at. Let's find it here. Cosecant squared, negative cotangent. No. That's only when you're doing the antiderivative and when you're integrating, we don't need it. Okay? Unless it's in, in this one, you're correct, Emily, we do need it because there's no a to b. So we're not actually looking at a space, so we will put it at the end.
And did you need to take the 6 out?
No, it was just showing that you can,
okay,
and you get the same answer.
Okay.
So yeah, you didn't have to take the 6 out. They're just proving the rule here. So this right here is that. This right here is 2. And then as Emily said there, yes, we need to see, just because this is a generalized, we're doing a indefinite integral. So since we're not actually looking at a specific section, we will put the plus c because we don't know how far we're going or where we're going. Okay. So example 4, go ahead and try this one. I'll let you try that one. That's okay, 267. We'll go through it here and see where you messed up. So first, we're going to do each piece. If you want to write them all out separately, you can. But the point is, guys, is that you integrate, you do antiderivative of each piece. Okay, that's all it means. So this one right here, hope you're seeing it. And you know it's going to be x to the 4th. When I drop a 4, to make that a 2, it's 1/2. So that's going to be 1/2 x to the 4th for the first piece after the antiderivative. Okay, I want a 3. I have a 3, so that means it's just x cubed. I have a 7. It's going to go to a 2. So 2 comes down to make it a 7, means this was 7/2. And then the last is just going to be 2x. Again, you can put the plus c, but it's not relevant towards the fundamental theorem of calculus because we have our a and b here. So now we need to go big F of 5 minus 2, right? Okay, so you put the 5 in. Ooh, 5 to the 4th, 125. That's 525? No, it's bigger than that. What is it? No. 625. Yeah, there we go. Thanks. So 625. So 625 over 2 minus 125. 25. 25 times 7 is 175 over 2. And then 25 or 5 times 2 is 10. So that's our first piece. That's our f of 5. 16 over 2 is going to be 8 minus 8 plus 4, 2, 14 plus 4. So if I subtract these, that gives me 550. Oh, that's an addition. That gives me 800 over 2, 400 minus 125 gives me 275 plus 10, 285 minus 28. What did I mess up on? What's that? Ah. What was the answer, though? Oh, well, that's good. Almost, right? Okay, good. 267. Okay, anything in there get lost? Okay, all right, we got 2 more here. So this one actually looks really hard, but it's not too bad because we're just going to write it like this. So if it's a negative 2/3 now, what was it before? Huh? Sorry, I can't hear you, Emma. A 1 over 3, yes. Add 1, right? That's all I got to do. Add 1. So you know it's a 1/3. So if it's a 1/3, what was in front? Because there's nothing in front now. So if I drop a 1/3, what would I need to be here? A 3. Good. That's what it is. That's your antiderivative. So f of 0 minus f of 1.
No, it's f of 8.
Oh, f of 8. I lied to myself. Thanks. Glad you guys are here. Yes. So we're at negative 2/3 to start. So we added 1 to negative 2/3, we got 1/3. That's where the 1,
And then you have to cancel.
right. The 3 comes because when I drop the 1/3, I need that to go away because there's nothing here in the, right there. right. Okay. All right, so here we go. Plug 8 in. Cube root of 8 is 2 times 3, 6. Cube root of 1 is 1 times 3 is 3. 3 should be your answer for that one. We got one more. Questions? All right, this one here. 1 over x squared plus 1. Huh? Yeah, this is the one that we want to steal negative tan, exactly. So this is where you freak out, but you want to check your sheet first. Okay, another thing I'd tell you is when you see something close, like what if everything had a 3? You pull that 3 out, put it in front, and get that to be negative tan. Okay? So making sure you kind of see that. So yes, this is the negative tan, or tan inverse, technically. It's like that. That's on your formula. So right here, 1 over x squared plus 1 is tan inverse. Yep. So we need to do we all understand that tan inverse is the same thing as cotan or 1 over tan, right? Okay. If I put 1 in there, what do I get? So according to my notes here, I did them in radians. You're going to get decimals, but this is kind of where you want to think about where's tangent 1? At the top right. Let me see here. On the directions there, let me check the directions. Okay, so where it's 1 is the top right there at pi over 4, root 2 over 2. Root 2 over 2, or root 2 over 2 is 1. So this right here is pi over 4. This right here is 0. Tangent 0 at 0. Okay, so the answer is pi over 4. And that could even be, even if you put in your calculator, it should give you the same thing. Pi over 4, so you'd get like 1 point something, or a little bit less than 1.
No, it's like
0 point, yeah, a little less than 1, yeah. Okay. Okay. All right, so